Okay, today we're going to talk about the fundamental theorem of algebra. And the fundamental theorem of algebra says that every polynomial has the number of degree roots in the complex number system if we count multiplicity of roots in it. So if a root occurs 3 times, we do have to count it 3 times. So, and it also says that those complex zeros, so complex numbers, a plus bi, well, a real number like 3 is 3 plus 0i. So it is still a complex number. The non-real complex numbers, though, will always occur in conjugate pairs for polynomials with real coefficients. So this one here has roots at x minus 2i, or it has a root at 2i, because 2i makes this first factor 0. And it has one at negative 2i, because negative 2i makes the second one. And they always occur in conjugate pairs. So we're going to multiply this out and find out what the polynomial is. So to multiply this out, I'm simply going to FOIL x squared plus 2ix minus 2ix minus 4i squared. The plus 2ix and minus 2ix cancel out. I squared is negative 1, so that changes minus 4i squared to plus 4i squared. Okay, we'll do another one. Yes, technically I'm supposed to write the I after the square root, but I think it just is clearer in front. So I write front. Okay, when I do this, I want to start by foiling my complex solutions, or my complex factors. So that becomes x squared minus I square root 2x, put the x in front, plus xi square root 2 minus I squared times 2. My middle term cancels. X squared minus I squared is plus 1 times 2 is positive 2. Now I will multiply these two factors together. Okay, and that is x times x squared is x cubed. Always make sure to simplify this as much as possible first. Makes the next multiplication easier. Plus 2x minus 5x squared minus 10. And I should put that in proper order. Okay, so we're going to talk about writing a polynomial given the roots. So I'm given these 3 roots. Okay, I know because complex numbers always occur, complex roots always occur in conjugate pairs, that I also have a root at 2 plus I. So they didn't give me that root, but I know it because I have to have conjugate pair roots. So to write my polynomial, for a root of negative 3, I have x plus 3 for a linear factor. I have x minus 4. These complex ones, x minus 2 minus I. So because this is positive, it's a minus there. and x minus 2 plus I. Now, you could put these in parentheses. That would work, but you don't really need to because they're both here. So now I am going to multiply them out. And to multiply them out, I'm going to FOIL the first ones. X squared plus negative 4x plus 3x minus 12. And this one gets a little messy. X squared minus 2x plus ix minus 2x plus 4 minus 2i. So I did x times all three, now I'm doing negative 2 times all three. And finally, negative I times all three. Negative ix plus 2i minus I squared. Now, assuming I did this right, my ix cancels, my plus and minus 2i cancels. I've got minus 4x. 4, that's a plus 1 becomes plus 5. So now I'm down to a trinomial. That makes that a lot easier. Still a pain in the butt, because now I still have to multiply two trinomials, but it's a lot less than, say, this 9-term polynomial. So always make sure to simplify. Your i's should cancel out. Now I'm going to multiply x squared times all three. Squared minus 4x cubed plus 5x squared. Now I'll multiply x times all three minus x cubed plus 4x squared minus 5x. And then finally 12 times all of them. This 12x squared minus 48x minus 60. We'll do plus negative. Now I combine like terms. Oh, I don't know why I wrote the first one as x squared. That's x to the fourth. Squared times x squared is x to the fourth. Okay, so I've got that corrected. My x cubed minus 4x cubed. I'm just going to put a mark by everything so I know I included it. My x squareds. 5x squared plus 4x squared is 9. Minus 12 is negative 3x squared. My x terms are negative 53x minus 60. They've got plus 43x. Yep, that should be a plus 48. Okay. Very easy to make a mistake here. So yes, negative 12 times negative 4x was plus 48x. 48x minus 5x is plus 43x. And that is the polynomial with these roots. Okay, one more example here. And this one has roots at x equals 1, x equals 1 plus 2i, and x equals 1 minus I. Now again, with conjugates, I know I also have 1 plus I and 1 minus 2i. So writing my polynomial in factored form, this is going to be a 5th degree once I get done with it. Starts with x minus 1. X minus 1 plus 2i. X minus 1 minus 2i. X minus 1 plus I. And x minus 1 minus I. So I have both conjugate pairs. So with there being 5, I'm going to FOIL out the two sets of conjugate pairs, or multiply them out. My x minus 1 is going to stay in front. And I get x squared minus x minus 2ix minus x. Now I'm onto the -1 times all three, plus 1 plus 2ix. Now I'm onto the 2I times all three. 2ix minus 2I minus 4i squared. I'll just simplify this down right away. X squared. Take a little tick here. Minus 2x. My 2ix's cancel. My 2i's cancel. I've got 1 plus 4 is plus 5. So that's x squared minus 2x plus 5. X minus 1 there. Now we're going to FOIL this one out. X squared minus x minus ix. Now I'm onto the 1, this 1 in the middle, times all three, negative x plus 1 minus I. Now I'm onto the I plus ix minus I. Nope, that should be plus I. -1 times. I knew I was wrong because I know it has to cancel out. And minus I, and then minus I squared. So I knew I was wrong when my i's would cancel. So that's how I knew that this first one had to be a plus. So I can cancel those, I can cancel these. Get x squared minus 2x plus 1 and negative I squared being positive 1, 1 plus 1 is 2. Now, usually I try to multiply sets of 2 together. I'm going to take the first two here and get x cubed minus 2x squared plus 5x minus x squared minus plus 2x minus 5. And I'm still multiplying that by this. I'm going to simplify it first, though. Minus 3x squared plus 7x minus 5. And that's correct so far. Just wanted to double check since I have an answer key. Now I'm going to multiply x cubed times all three. Minus 2x to the fourth plus 2x cubed. Now negative 3x squared times all three in the second parentheses. That's negative 3x to the fourth. My plus 6x cubed minus 6x squared. Now we're on to 7x times all three in the final parentheses. So 7x cubed minus 14x plus 14x squared plus 14x And finally, 5 times the final parentheses, or -5, plus 10x minus 10. X to the 5th, now we just start combining like terms, minus 5x to the 4th. 2 plus 6 is 8, plus 7 is 15, x cubed. Now we get to our x squareds. -6 and -14 is -20, -25x squared. 14 and 10 is plus 24x minus 10. And that is correct. So this is my 5th degree polynomial with roots at 1, 1 plus 2i, 1 minus 2i, 1 minus I, and 1 plus I.